So again, good morning, good afternoon, good evening, whatever it is where you are. Welcome to the last session of the day on the first conference day here at SQLDay Poland 2021. And welcome to Azure SQL Anywhere Azure Arc enabled data services. Before we get started, thank you very much, of course, to the sponsors and partners of this conference that make this possible, because even though we're not in person, these things do cost money to run. So thank you for that. And also thank you very much to the organizers to actually set this up and invite me to speak here. We will talk about basically three things today. We will have a brief primer. We'll be talking about virtualization, containers, and Kubernetes. We will very briefly talk about Azure Arc. Then we will talk a little bit more about Azure Arc enabled data services. And then we will do what I personally love most in technical sessions. When it's about new technology, we will be very demo heavy. And I hope the demo gods are with me, because Bug Woody in his presentation just before this one pointed out again that we should pre-record our demos. And of course I did not, but I'm a very brave person. So let's see if that pays off or not. If you have any questions during the presentation, just raise your hand, just put it in chat. I will try to monitor the chat and also monitor any raised hands. And then interrupt me whenever you see fit, and I will take questions as we go. I want to keep this as interactive as we can, and I hope this avatar land or avatar thingy here helps a bit with that. I usually chat a lot during my sessions, so yeah, support me a bit and be as interactive as you can. So whenever you have questions, just let me know. With that, very few words about me. My name is Ben Weissman. I've been working with SQL Server since SQL Server 6.5. I consider myself a data passionist at heart, so anything around data, I work on that, and I want to get my hands on that, any kind of new technology. I also run a couple of my own events. One of them that still has its call for speakers open, which you see on the lower right corner, which is Dataverse, which is a conference where we're trying to support and enable diversity in our data community. So if you think you might have something to present or something to say that people should listen to, and you think you also feel like you're a bit underrepresented, or you're a part of an underrepresented group at the other major conferences, maybe this is the conference for you. Our call for speakers is still open, and we'd love to see your submissions. And having that said, let's get right to the content. We start, like I said, with a bit of a primer, and Mr. Bug Woody, who is with us, may have seen these slides before. I shamelessly stole those first couple of slides from him. Virtualization is something that most of you have probably been working with for a while. It kind of depends on your role, depending on if you're on the front end, back end, DBA, whatever department of the house. You may or may not care what kind of infrastructure your SQL service, your data estate is running on. But I assume most of you are familiar with virtualization. The idea of virtualization is that a couple of years, or at this point decades ago, we just came to a point where we said, well, it doesn't make sense anymore to just buy bare metal, to just buy dedicated hardware for every single application, for every single database that we're running. So what we started to do is we started to virtualize things using ESX, using Hyper-V, using tons of other platforms. And the idea of virtualization is that on top of your operating system, which can be Linux, which can be Windows, you're running a hypervisor. And then on top of that hypervisor, you're running virtual machines. And just like the physical host, every single one of those virtual machines, it will have a disk, it will have memory, it will have network, it will have CPU. So you end up with a very high degree of redundancy. High degree of redundancy from a disk perspective, because in my example here, we're running 3 different virtual machines, all more or less the same, still wasting 3 times the storage for the operating system alone, and probably also for applications. Like if you're running 3 different SQL servers, you end up having 3 different disks, and all of these 3 different disks have the Windows operating system, including all of its patches, and the SQL server, including all of its patches, and so on. And you also have the redundancy from maintenance perspective, because that also means every single time Microsoft releases a CU, a cumulative update for that SQL server, every single time it's Patch Tuesday and Microsoft releases new patches for your operating system, you have to go ahead and apply those patches to every single one of those machines. And even though I'm aware that there's ways of simplifying that using Windows Service Upgrade services, using PowerShell and tools like that. It's still something that needs to be monitored. It's something that needs to be done, and it's something that needs to be taken care of. And it gets you into a lot of redundancy from a maintenance work perspective. So that's how we came up with, or well, not how we came up, how we ended up with containers, I should rather say. The big difference between a container and a virtual machine is that instead of the hypervisor, you have the container runtime, and a container, and think of a container, something like an image, an ISO file that you download. The big difference is the container does not have its own operating system. It shares the operating system of its host, which also means on a Linux machine, you can only run Linux containers. On a Windows machine, you can only run Windows containers, unless, of course, you're running a virtual machine and run the containers in there. The cool thing about these containers is, first of all, they are super lightweight because most of them run on Linux, and Linux is just way more lightweight than Windows. I think that is a fair statement and assumption to make. And by using those images, let's assume you have an image that is running SQL Server 2019 CO9 in a container. And you're running that SQL Server in 3 different instances. So you're actually running 3 SQL Server 2019 CO9 instances in a container-based environment. If you need to upgrade that, all you need is you download the latest image for CO10, CO11, CO12, whichever the one is you need, and then you spin up a new instance of that container. So instead of wasting 3 times the disk space, you're only wasting, quote unquote, because I mean, if it's only once, there's no disk space wasted. Once the disk space, and also for the upgrade, you only upgrade that image once. So way more lightweight, way easier to maintain, way less disk space that's being wasted. One of the issues that you get with these containers is they don't talk to each other very well. So what you need is some kind of orchestration. And you may have heard of Kubernetes, which is a very famous container orchestrator. It was originally invented by our friends at Google under a project called codename Borg. And the idea of Kubernetes is you bring containers together in so-called pods. So to run a specific application, instead of putting everything into one container, you may need 3 different functionalities to have that application up and running. So you take these 3 different containers and pair them in a pod. And of that pod, you can have 1 or more so-called replicas. So if I want a SQL server that has more than 1 instance, you will just deploy more than 1 pod of that SQL server. We're actually going to see that in the demo of Arc-enabled data services. Those pods still live, obviously, on some kind of hardware, and that can be physical or virtual hardware. So depending on your workload, you would either deploy VMs or you would deploy physical hardware. If you're running something super big, something like a SQL Server 2019 data cluster, that might warrant something like dedicated hardware. Whereas if you're running something rather small, like a microservice, there is no point in running tons of dedicated hardware just for that. So depending on the use case, you will then have not just 1 node, but actually a bunch of nodes, always accounting for redundancy and all that. And the control plane, the orchestration master of Kubernetes, will make sure that your workload is spread evenly across those nodes. It will also make sure that if an application, or rather a pod, is being deployed to one of these nodes, that node actually supports it. So if you're running this because there is not one Kubernetes, I think Kubernetes is kind of a system, but it runs on, you can run that as part of Docker, you can run that in the cloud, in Azure, as Azure Kubernetes services. You can run it in the Google Cloud. You can run it in the Amazon Cloud. You can run that on Red Hat Linux, or you can run it on something called OpenShift, which is basically enterprise Kubernetes from our friends at Red Hat. So that is what Kubernetes, and you may have some nodes that run Windows and some nodes that run Linux to support different workloads within your Kubernetes clusters. So the orchestration master will also make sure that it's only deploying workloads or pods to machines that actually support it. And the interesting part is storage will usually be, well, not usually, will pretty much always be, unless if you do something very lightweight, what I'm doing here, and just have local storage, separated. So it will not be part of that node. So you will have some kind of external storage that is able to move along these nodes. So if a pod moves from node A to node B, it can basically take all the data of that pod with him. So a pod is never recreated. So a pod technically also doesn't move. A pod can be terminated on one node, and then a new, completely new pod with a completely new ID will be spun up on another node, or potentially even the same node. The important and interesting part is it takes the storage with it. So from a user perspective, from an end user or DBA perspective, you're still talking to the same data in the background. You're still accessing the same persistent data, even though something in the middle may have changed. And the great thing about that is that you can start scaling containers. They share the operating system of their host. So they don't bring their own operating system. So Linux containers only run on Linux operating system. Windows containers only run on Windows operating system. The smart thing about containers is you have images instead of full-grown virtual machines, and an image can be spun up into memory multiple times, as many times as you want. So if you're running one SQL Server or 10, you're only using the disk space once, and if you're upgrading it, you're only upgrading it once and then just respin up those instances into memory. So way less footprint, way less maintenance work, and way less wasted disk space. Then, when I came to this Kubernetes thing, let me just also briefly summarize this. Kubernetes is an orchestration tool, or an orchestrator for containers. So what it does is it groups containers that belong together to form an application into pods. That's what they're called. A pod is living on a node. One pod can only live on one node, so you can't have a pod that is spread across multiple nodes. So you also have to make sure that you're sizing your system accordingly. A node is a PC or a VM, so any kind of hardware below that. So Kubernetes is basically just abstracting the infrastructure away. And there's not just one Kubernetes, but all kinds of Kubernetes implementations. And the nice thing is you still have that one single interface that you can talk to it. So if you're deploying an application to AKS or to GKE or to a kubeadm or to Docker, as long as it's Kubernetes, it's basically the same thing, and it's basically the same script, and it all runs through code. And storage in Kubernetes is always separated from the compute part, unless if you're doing it super easy, as like I'm doing it today, with the point being that storage can move from one node to another if a node goes down or a pod has to move from one node to another for any specific reason. And the cool thing about that is that you can actually scale your cluster by a purpose. So if you're running a SQL Server big data cluster, for example, if you've heard of that before, or maybe even worked with that before, in a big data cluster, you will have different kinds of pools. You have something which is called the storage pool, which is basically HDFS within SQL Server. Super cool. SQL Server bringing its own file system. How cool is that? But there's also the data pool, which allows you to scale one single SQL Server table across multiple actual SQL servers, partitioning kind of across servers. How cool is that? But depending on your workload, you may need one of or less of one or the other, so you can actually scale by that specific purpose. Fun fact, big data clusters is also the first, flavor of SQL Server, you would want to call it that way, that only deploys on Linux, which is also kind of weird. But today we're talking about Azure Arc enabled data services, so let's not get too much down the BDC rabbit hole. So what you will need to note for today about Kubernetes is it uses containers, so not virtual machines. It mostly runs on Linux, even though there's Windows implementations of that as well. Main reason for that is Linux containers way more lightweight than Windows containers. And it helps us to abstract infrastructure away and deploy everything through code. And we will see that in the upcoming demo. If you want to learn more about Kubernetes, I have a book that I can recommend you, which is the Illustrated Children's Guide to Kubernetes. It's actually a free book, so you can download the PDF. I know that the link is too small in here, but once you get the materials, you can just click it or just Google for that. Jakub is typing something. You can just Google for that book, and the book will, you can download it for free, or you can have it shipped to you as an actual printed book for a couple of euros or a couple of dollars if you prefer that. I highly recommend you this book here, the Illustrated Children's Guide to Kubernetes, which is written like a children's book and explains all the concepts of Kubernetes very well on about 30 pages, and it is free. And with that, let's talk about Azure Arc. Azure Arc, basically, my friend Anthony Nocentino, he put it in the way that it's an overarching umbrella to get ARM anywhere you have stuff code. And that basically means you go to any cloud, or it doesn't even have to be a cloud, it can be on-premise, pretty much any infrastructure and any Kubernetes, and you combine Azure with that world. What that means is you bridge infrastructure that is running on-prem or in another cloud like the Google Cloud or AWS into the Azure Cloud, or as in the case of Azure Arc enabled data services, you bring services that were previously reserved for the Azure Cloud exclusively to any other cloud, like, for example, a SQL Server Managed Instance. How does that work? What you do is you take you start with a Kubernetes cluster, like I said. So you take a tool called kubectl or kubectl and deploy a Kubernetes cluster. And that Kubernetes cluster will be Arc enabled. That's just an extra pod running in that cluster. And we're not going to go into details of that today. And then you can either use kubectl again, or you can use a tool called Azure Data CLI or AZ Data to first deploy the Azure Arc Data Controller. The Azure Arc Data Controller is kind of the backbone of your Azure Arc enabled data services deployment. It doesn't do much on its own at first sight, but it is super important because what it does is, first of all, it runs the provisioning and deployment of services, but it also runs the communication between your local or other cloud Arc environment with the Azure Cloud. So this is also the one that will be responsible to communicate with the Azure Cloud. You could also run that deployment through Azure Data Studio if you prefer a graphical user interface. You can even deploy something on-prem using the Azure portal. How cool is that? You can go to the Azure portal, and what you would do if you're familiar with how Azure is structured, usually you would deploy something into a resource group in a region, and that region would be East US or North Europe or Southwest Australia too, or whatever they're all called, with pretty much new regions popping up on an hourly basis, kind of. And what you can do in this case, or in the case of Azure Arc, is you can create something called a custom location. So my custom location could be my on-prem data center. And in that my on-prem data center, I can then start deploying Azure services in my local environment, on my local own hardware. And the actual services that we will care about in the end are, at this point, an Azure Arc SQL Managed Instance or an Azure Arc database for PostgreSQL. So a managed instance, something that is, up to now, completely reserved to the Azure Cloud, something that you could only get in the Azure Cloud. You will get that on any infrastructure. So you can run an Azure Managed Instance or an Azure SQL Managed Instance on AWS or on your own hardware. I could go ahead and deploy a Azure SQL Managed Instance on my notebook, and I would still get many of the benefits that I would get from the regular quote-unquote SQL Managed Instance, with, of course, the exception of the hardware part. Since I'm responsible for the hardware, I cannot call Microsoft if there's a problem with the disk, because it's my own disk. So that's kind of the difference. But there are so many reasons why you may not be able to move everything to the Azure Cloud, because you're running a multi-cloud strategy, because you've just acquired another shop that is completely on AWS and will just take time to merge everything, because you're running on the edge, you're running a retail store, and just because you're losing your internet connection does not mean that you actually want to lose the ability to sell stuff to people. That makes sense. Or you're an oil rig, which is also a super popular way of, or a super popular example for running something on the edge. When it comes to deployment, this goes even further. Since everything in Kubernetes is run through code, you can use Git merge and Git operations to actually deploy and keep everything updated. So potentially every single time you check in your new code, you can use Git and Git options and Git operations to basically rebuild your complete infrastructure using the Azure Arc environment. Of course, you also want to monitor that stuff. So Azure Arc enabled data services come with two built-in portals, the Kibana dashboard and the Grafana dashboard. Grafana is for metrics. So Grafana will show me how much CPU usage do I have, how many logs do I have in my SQL server, how many weights do I have, all that kind of information. So for the physical, for the pod, for the application, in this case, side of the house. And Kibana is for log files. So I can use Kibana to analyze my SQL Server log, but I can also use Kibana to analyze my Kubernetes log. So those are the two built-in tools still. That may remind you a lot of stuff that you already have in Azure using the Azure Monitor. And to do that, you can take the metrics and your log files actually from the Arc data controller and push it to the Azure portal. And there's two ways of deploying Azure Arc-enabled data services, a direct mode and a so-called indirect mode. If you're in direct mode, the Arc data controller will just constantly push those log files and metrics to the portal. So there's no need for you to interact. And if you're in indirect mode, which is because you may be in a disconnected scenario or you want to save bandwidth on specific times of the day, or whichever your reason might be, you can just manually push them to the portal whenever it works for you. So what Azure Arc-enabled data services does in a nutshell is it gives you a SQL Managed Instance and PostgreSQL hyperscale environments on any infrastructure, including on-prem. Pretty cool stuff. Before we get to the demo, are there any questions? And what I will do is I will switch here and would ask either Hubert or Mikhail or Buck or any of you to confirm, can you see my Azure Data Studio?
Yes, I can see it.
Awesome. Cool. So fingers crossed the demo gods will stay with us for this. So I'm running here in Azure Data Studio. For those of you that are not using Azure Data Studio yet, please start using it. Azure Data Studio is not just for Azure. Azure Data Studio works for any kind of SQL, or not even just SQL. It, for example, also works for Postgres environment, wherever it is, being it on-prem, being it in a different cloud. So make sure to check that out. Azure Data Studio is not taking your management studio away, but it's complementing it very well. Actually, in the latest editions of Management Studio, Azure Data Studio is even bundled with that, but you can still also install them standalone or side by side, whichever way you prefer. And one of the cool things that you get in Azure Data Studio is, first of all, it's cross-platform. Second of all, it has a dark mode, which you can see I'm not too fond of, but I know many of you are. But even more important, you get something called notebooks. And a notebook, a Jupyter notebook, is a combination of code, text, images, and the result of that code. So it has a kernel. Every notebook has a kernel, and that kernel can be a SQL kernel or Spark or Python, or in my case, PowerShell. So I'm here in Azure Data Studio running a PowerShell script, and see, Buck, I'm running this live. Where I just say kubectl config use context. What I'm doing here is I'm pointing my notebook or my whole environment, I should rather say, to a Kubernetes cluster that I've prepared before. So I'm running this environment here on two virtual machines. I'm running one Linux machine that is running my Kubernetes cluster and one Windows machine. I could have also run my Azure Data Studio from the Linux machine because, again, it is cross-platform. So I can now use Azure Data Studio to create a new Arc data controller. And Azure Data Studio comes with a wizard for that. So what I can do is deploy that new data controller. What it will do is, first of all, will give me an error here in a sec. It will check for the prerequisites. Do I have kubectl and the Azure Data CLI installed? And do I have them installed in the right version? Check, I do. Which Kubernetes cluster am I deploying against? You may have multiple Kubernetes clusters, one in the Azure cloud, two in the Google cloud, one in AWS, and 5 on-prem. Which is the one, which is the quote-unquote server, because it's not technically a server, because it's a cluster, but which is the infrastructure that you want to deploy against? I only have one, so that's a super simple choice. It will then ask me what kind of Kubernetes cluster that is, because even though they are all following the same methodology, there's differences in the way they are set up and they are built. This one is a kubeadm cluster, so that's what I'm picking here. Next. And then it's just asking me, which Azure subscription do you want to use? So we're doing the MVP sponsorship here, H2S. And then it's asking me for a namespace. In Kubernetes, everything is organized in namespaces. Think of a namespace of something like a folder on your file system where you can just basically organize these pods that we were talking about earlier, which unfortunately you could not see. So I highly encourage you to just check out the slides afterwards. So that's kind of the folder name, the namespace, the name of the data controller itself, because you could have multiple data controllers running on the same Kubernetes cluster. What kind of storage are we using? I only have local storage attached, so that's also a simple choice. And then it's asking me for a password. So let's just key something in here real quick. And then I could either right away hit deploy or say script to notebook, and that's what I'm going to do. The cool thing I want to show you here is what this does is it creates another one of these notebooks that we've seen earlier, but this one is using Python instead of PowerShell. And all this thing will do is it will set a couple of variables and then run the tool that I've also mentioned earlier, AZ Data Arc DC create to create our data controller. What I could now do is save this specific workbook, this specific notebook, and run it anytime I like. So that also helps me, for example, with demos, where I could just rerun the same notebook. Or I could also say, well, I already got that set up. So I just run this specific command, AZ Data Arc DC create, providing the connectivity mode, also providing the name, the namespace, the subscription, all the things that this wizard was asking me before. So if you're deploying through that wizard or if you're deploying from the command line, it does not matter. What this does is kicks off the creation of a couple of pods in my Kubernetes cluster. Let's just do this and watch this for a moment. So deploying a new data controller takes roughly 2 minutes. If, and that's the big if you have either manually pre-pulled the images. Remember, all these containers, they are based on images, so these images need to be downloaded at least once. So if you've either manually pre-downloaded those, or if you have deployed a data controller on that same system before, because that will also trigger the pulling. Because what you see here is we have the different parts, for example, here the bootstrapper and the control DB, and our bootstrapper consists of one container. So one of these one containers is ready. 2 of my 2 control and 2 of my 2 control DB containers are ready. And let's just refresh that view so it becomes a bit more readable. And what you see here is we're now at 9 pods, sorry, some of them with 1, some of them with 2 containers. The last one, the management proxy, is running with 1 of 2 running. So this is the last one that's popping up. So like I said, about 2 minutes for the whole thing to come up. And once this is done, it will also report back in Azure Data Studio that the deployment is actually ready. What we already see in Azure Data Studio, even though it is still deploying, is the endpoint of our service. And what you also see here is on the IP address 192.168.1.4. For those of you familiar with private IP addresses, this is clearly a private network. So I'm not deploying this to any kind of cloud environment, but this is I'm running a Linux machine and a Windows machine in a local network segment. So what I can do is I can take that endpoint and connect to that endpoint using Azure Data Studio to manage it from there. In a sec, let me just see how we're doing here. Almost. We're just going to let that finish. Come on. Of course, it takes more than 2 minutes now because Buck is watching and told us not to do live demos. There we go. And the important part here is in that Arc namespace, we will later also see our managed instance. We will potentially see, we're not going to deploy Postgres today, but if we would, it would also show up here. So this is kind of the, and I'm deliberately using the word container, even though that's kind of misleading since all that is also running on containers, but different kind of containers. But this is kind of the collection where everything is happening. This is where all my Arc magic is happening, and I could code all that. So again, if I do kubectl get pods in my Arc namespace, I get all my 9 resources that it requires. So let's connect to this controller in the Arc namespace using my username and password. Let's remember that. Connect. And what this will just do is it will connect to this endpoint, and this will provide me everything that is in this cluster so far. Well, at this point, there is not too much in this cluster except for the data controller itself. So what we will see again is, okay, this is indirect mode. We're running in East US. This is the subscription it's running in. This is the resource group it's running in. And these are all the resources. Well, there are none because we haven't deployed any yet. So also if we say next thing, we also log into that instance from the command line. I could again use a wizard where I could say new instance. And I'm sorry, I'm doing all this a bit quicker than I wanted to, but I want to make sure that we get to the end, and we just lost a bit too much time with the tech glitches. But I will point you to resources where you can actually get through all that a bit slower. So apologies for that. Azure SQL Managed Instance, next. It will again check, do I have all my prerequisites installed, accept my license agreement, next. And then will ask me for a username, a password, what kind of storage, and how many replicas I will be using. This would again create a notebook that I could then deploy, or what I can also just do is Azure Data Arc SQL MI create. Let me actually fire this off and then show you what it does. So we're pointing it to a name, local MI01. This is just what we're going to be calling our managed instance. Our log files, and these log files are the Kubernetes log files, will be sitting on local storage. Our data file will also be sitting on local storage, and our data log files will also be sitting on local storage, because local storage is all I have here. But in a production environment, you may have something to say, well, my Kubernetes log files, I don't need those to be super performant, so those will sit on HDDs. My SQL log files, on the other hand, I want those to be on Ultra SSDs, and my SQL data files, they will sit on premium storage, or whatever kind of storage subsystem you have available for you to use. So those are the three classes for that specific case where you can point different kind of data, Kubernetes log files, data log files, and the data files themselves, to different kinds of storage, or as it's called in Kubernetes, storage classes. So if we take a quick look back here, what we will see is our local MI01 /0/0. We're not going to have a /1 or /2 because we're only deploying a single replica. And if we just kill this here real quick, just for visibility again, what you will see is local MI01, 3 out of 3 are running. It took us 84 seconds. And if we go back here, local MI01 is ready. So we now have a SQL Server Managed Instance deployed to my on-premise environment, and the deployment of that managed instance took 84 seconds. And the fact that I can, if I refresh this, you will also going to see this, the fact that I can first of all have a managed instance on-prem, and even more so deploy that managed instance in less than 2 minutes, even having worked with Arc-enabled data service for quite a while now, it's still, it blows my mind how this actually works. So if we also do Azure Data Arc SQL MI list, this would, just like I get it here in the UI, get me the endpoint of that specific SQL server. So this is my IP address, this is the port. So if I use this endpoint, I could connect to that using SQL CMD, I could connect to that using Azure Data Studio, using Management Studio, any of those. Or I could also look at it from the Kubernetes side of the house and get the Kubernetes service, where again, I would see the external port 32132 of that specific instance. I could now either connect to that, or I could run tools like SQL CMD even inside this container. So if I do a select add version on that, what it will tell me, hey, you're running Microsoft Azure SQL Database Managed Instance Azure Arc. So it's not the same managed instance that you would get on Azure, but pretty much, including the build number and so on and so on. And we're running on Ubuntu 20.04. So let's just connect to that endpoint real quick. SQL authentication, because we did not go through the hoops of AD integration here. So my password, connect to that. And boom, there we go. Whoops. We connected to our managed instance running on our Kubernetes cluster, which is not yet connected to the Azure cloud yet because we are on indirect mode. What I will do is I will skip this part and only copy an AdventureWorks file to this container. So what I can do here is manage, restore from a backup file. So what I'm just trying to show you here real quick is I just copied that file into that container. So the way you work with storage inside of containers is also slightly different than you would be doing that on a Windows machine. Hit restore. Boom, there we go. Our restore database is in progress, which should be fairly instant. There we go. And we have my AdventureWorks 2017. So despite all that running on Linux, which might be different from what many of us are still used to, because I assume many of us are actually still running their SQL data estate on Windows-based machines, I can easily restore my database in there, and I could now also either AD integrate that thing or create other users and have people use that managed instance as it is from any kind of client tools. Easy as that. I will also not execute this, but if you want to create an availability group, it's basically the exact same command that we've used before. There's two differences. First of all, I'm calling it localmi02 instead of localmi01, so just giving it a different name. And all I'm doing is I'm adding the switch replicas 3. So what this will do is instead of a single standalone SQL managed instance, it will create 3 instances and connect them to an availability group. And every single database that you would restore to that group will by default also be part of that availability group. And also that deployment will take about 2 minutes. So it will take just about the same time as a regular deployment. So we may actually get to that part of the demo at the end of the session, but with 8 minutes left, I still want to show you the connection to the Azure portal and also the other built-in portals. So what I can do here is, and well, there's many different ways of actually retrieving those endpoints, but the easiest way is going through Azure Data Studio. I just clicked on my instance, and like I told you earlier, we have the Kibana and the Grafana dashboard. And what I can do is I can just click here, connect to my Grafana dashboard, which will again ask me for a username and password, which are the same that I've used when I've deployed that thing. That and I'm getting metrics for my SQL managed instance where I can see those mind-wobbling 100 transactions per second, which is what happened when I actually just restored that database a couple of minutes ago. And if there would be more than one managed instance, I could just pick it here. So this is my looking glass into everything that's happening from a managed instance perspective in this specific Arc-enabled data services deployment. But I can also take a look at what's happening on my host. How long has this host been up? What's my CPU usage? What's my RAM usage? And so on. Excuse me. I could take a look at specific pods and containers. What is actually eating my memory? What is actually eating my CPU? Where am I potentially losing performance? Where have I potentially over provisioned my system? All that is stuff that I would get from here. And if we had deployed a Postgres instance as well, which we have not, it would show up here. At this point, there is no data to show because we have not deployed any of those instances. And on the other hand, like I said, we have the Kibana dashboard. So let's log in here as well real quick. And what this will do is it will help me read my log file. So as you can see, you have data coming from, well, the Kibana pod itself, for example. But I could also search for backup, or rather for restore, actually. And boom, backup restore database successfully processed so and so many pages in so and so many seconds. So you get the log files from Kubernetes itself, as well as the log files from any application running on that cluster. So again, if you're running not just one managed instance on there, but potentially running 20, 50, 100, how many ever SQL instances, managed instance, or just regular SQL on Kubernetes, you would get all those SQL log files in here, in one central looking glass. So also something pretty cool, and you get that out of the box. Still, I was promising you earlier that we would also be able to connect this to the Azure portal. So what we will need to do for that is, first of all, I need to log into Azure. So I need to log into my account. Using the AZ command tool, so the Azure CLI. So I'm doing AZ login, setting it to the proper subscription. And then what I will need is, the first thing I need is a service principal. Think of a service principal like a service account or an agent account sitting in Azure that you can use to run jobs when you're not there. So it will just use its own identity and will get the proper permissions for that to actually upload those log files for us. Giving it a specific role assignment, monitoring metrics publisher. Then we will need a log analytics workspace. So basically a folder kind of, well, it's a little bit more than a folder. So if anyone from the log analytics product team is ever watching this, forgive me for saying it's just a folder. It's way more than a folder. So we're creating a log analytics workspace. So we do AZ monitor log analytics workspace create. This will create all that for us. And once we have that, I'm actually retrieving the ID of that workspace and saving it into an environment variable, and also the access key. So using the ID of my service principal, including its password, the ID of my log space, including its password, I will be able to communicate with my Azure portal from my on-prem environment. Since I'm in indirect mode, what I will need to do, and this could be happening on a scheduled basis, this could be happening manually, whatever works for you, whatever works for your use cases. The first thing you do is you export that data. So what this will do is it will take the metrics and the log files and just save them to JSON files. And in the next step after that, which is the more important step actually, we will go ahead, let's just clear this up, and do AZ Data Arc DC upload, where we can take that data and push it into the Azure cloud. So while this is running, I will navigate to my Azure portal. So in my Arc demo, let's get rid of this.
Ben, I just wanted to remind you that we have only 2 minutes.
Yes, I'm aware of that. But thank you. So how are we doing here? Okay, they have all been uploaded, so we should be able to see this. And of course, there is a lag on the portal side of the house. It should be instantly, but sometimes it takes a minute or two. We would now be able to see, I will just hit refresh one more. There we go. We got the Arc data controller and also our managed instance. And I could now go ahead and say, hey, show me those metrics again. I want to see SQL metrics. I want to see the CPU usage. And here in the Azure portal, I see the CPU usage coming from my on-prem SQL managed instance. Again, how cool is that? Sorry that this was a bit bumpy. There was a bit more stuff that I actually wanted to show you. But yeah, some technical glitches did not allow us for that. If you have a Pluralsight subscription, if you go to bookmark.w ws/arc data course, it will take you to my course on Arc enabled data services, where I'm actually walking you through all this at a much slower pace. I also had the pleasure of writing a book on that topic with my friend Anthony Nocentino. If you go to bookmark.ws/arc demos, you will find the demos of today. And also here are my contact details. You will find me on Twitter, you can find me on email, and you can find me on LinkedIn, and well, in theory, a couple of other platforms. So again, apologies that this was a bit bumpy. I hope you got a brief idea, at least, of what Arc-enabled data services are. Arc-enabled data services bring services like a managed instance that is usually exclusive to the Azure cloud to your on-prem or any cloud environment, still giving you stuff like managed backups, managed updates, but on your own infrastructure. So if you cannot move to the Azure cloud for whichever reason, this is definitely something for you to look into. There, as you have seen, everything we did was live. So in the last 20 minutes of the demo, we have deployed the controller, we have deployed a managed instance, we have monitored that managed instance, we have uploaded and connected to the Azure portal. So creating a new SQL server in less than 2 minutes, even a managed instance, which in the regular Azure world takes sometimes a couple of hours. If you ask me, that is pretty cool stuff. So if you want to relive that, if you do not have a Pluralsight subscription, feel free to hit me up, and I may be able to get you a trial for that if you've already used up your regular one. And again, apologize for these hiccups. And if you have any questions, we have nothing going on here, so I would just stay on this stage for your questions. And otherwise, we also have the Q&A in 10 minutes in the auditorium. So thank you very much. Again, apologies. And if you have questions, feel free to either raise your hand or just use chat for that. Thank you.